If you want to create your first deep learning application for classifying the contents of an image, you are looking for a set of images and how to load them. In this quick tips episode, you will learn how. Keep watching. Hi there! I'm Manuel Gutierrez from thelighthouse.co, and I make videos that help you learn about different programming topics like AM, Docker, TensorFlow, Unity, and more. So, if you're new here, hit the subscribe and the bell notification buttons below so you don't miss a thing. Let's start! This video is part of the ASL classification series where you'll implement a simple deep learning model using TensorFlow and Keras for classifying images. First, we define the problem that we want to solve, identifying hand signs for the American Sign Language ASL. Then, we collect or download some data representing examples of what we want to learn how to classify. Images of hands representing the ASL fingerspelling signs. This video, we define and train a model that can capture, learn, and classify the visual data. We evaluate the performance of the model to see how well it is classifying images. Finally, we use the trained model for predicting hand signs. Don't forget to join the free mini course in the description below. In this video, for the Deep Learning ASL classification series, I will talk about where to find a dataset for ASL and how to prepare it by loading and normalizing the images, and also how to pre-process the labels for each sign. Typically, when we are learning something new, like a new spoken language or ASL, a teacher prepares the learning materials. In this case, a bunch of signs and labels to teach us in a format that is easy for us to understand. We get an example of what we are learning, a word, or in this case, a hand sign. We are told what that sign means or its name or label. This is an A. The teacher follows the same process with the remainder set of the examples and labels until they are exhausted. Then, oh joy, we get tested to see how much did we learn, and if our scores are below some threshold. For example, let's say that we just managed to recognize successfully 20% of the signs that we saw. Then we start over by watching the hand signs and labels again and by being evaluated again. The process repeats until we get enough right predictions to be able to say that we now know how to fingerspell a word correctly. A dataset is a set of data, or in this case, images, with signs and their respective labels so that we can start learning how to recognize them. You can find several datasets if you go to Kaggle and look for the data that you need, like for example ASL. For this series, I am going to use this ASL dataset, which has some particular characteristics. It has a solid black background. Each sign takes the entirety of the image, and signs are centered within the image. Once you've downloaded and unzipped the dataset inside the dataset/train folder, you will be able to see that it consists of several folders, where each folder contains the sample JPEG images for a particular sign. So, if we open the folder called 2, we will find images for the number 2 sign. First, Inside that function, create an array for storing the images and also one for the labels. Create a for loop to iterate through all of the JPEG files inside the source folder. Now that we have the paths for the files, I am going to extract the images parent folder to use it as the label. Then I am going to load the images in grayscale using OpenCV. Resize it from its original width and height, and normalize each pixel so that instead of its values going from 0 to 255, they go from 0 to 1. Finally, define the source of our ASL dataset and get the images and labels from the function. Let's also create a function to plot the images in a row with their labels on top, and plot a little sample of images and their labels. I'll one-hot encode the labels here. You can watch my video about one-hot encoding to know more. First, I will use the label encoder to get numbers out of string labels, and also to get the labels from integer numbers. Then I will one-hot encode all the labels for training. I will use scikit-learn for splitting our one dataset into two randomized sets, one for training and one for testing the performance of the model. In the next video, I'll start by creating a model for classifying images, and then we will train the model. Awesome! Congratulations and thanks for watching! You can join the free mini course associated with this video by clicking on the link in the description below. Share any comments or suggestions about the series or future topics. And if you like the video, also hit the like button below.